Um,
Hello. Okay, I guess we can start now. Hello, am I audible?
Yes, sir.
Okay, great. So in today's session, we'll discuss about the week 10 part. Okay, and we'll solve all the questions from PA week 10. So I guess deadline for week 10, 13 only on Wednesday. So we'll need to complete all PA week 10. Okay, no worries. Is my screen visible?
Yes, sir.
Okay, great. So week 10 is basically application of a graph theory, like what we have discussed in week 9. Okay, so you can see whatever we have discussed in week 9, same thing we are going to apply it here. Okay, so first we'll discuss about a different, like we quickly revise about the graphs here, right? Now let's say, for example, I have this graph. Okay, so what I have 0, 1, 2, 3, 4. Okay, so like this. Okay. So if I have this node I and this node j, and if this line is there, okay, there is no arrow from I to j or j to I, it means what? It is undirected graph, right?
It is undirected.
Yeah. And whenever I have I and j, so here you can see this particular arrow, this is basically directed graph. Okay. So in this case, I can go from I to j as well as j to I. But in this case, I can only go from I to j, not j to I, because here you can see arrow. This is basically directed graph here. Okay.
Sir, is undirected graph also represented by double arrow? Means arrow on both head.
Yeah, that also you can see, but we don't generally represent like this. Only we have this one line or simply arrow here. That's it. Okay. So we don't use
So,
double
so the
arrow.
double arrow is directed or undirected?
double arrow is, you can see, we can go in both the directions, so undirected here, okay? But we don't represent like this only, or a single a line like that, okay, without arrow. This is undirected, here you can see directed, okay? And let's say, for example, we have this a graph, a G here, and this is basically undirected graph, and let me draw a few arrows here like this, okay? Okay, so it means what? I can go from 0 to 1, but not 1 to 0. You can see here 0 to 2, I can go from 0 to 2 as well as 2 to 0, because it is a undirected edge you can see here. It is a directed edge you can see here. Okay. Now we have this particular graph here. Now, do you know what is adjacency matrix? In week 9, we have
Yes,
discussed about
ij.
adjacency matrix,
Yeah,
right?
ij. Yes, we have 0 or 1.
Yeah. So let's say, for example, M represent this adjacency matrix here. And how many nodes we have? 1, 2, 3, 4, 5, right? So 0, 1, 2, 3, 4, right? So here also 0, 1, 2, 3, 4. So it's a it's a 5 by 5 square matrix because we have 5 nodes here, right? And what are the element of this adjacency matrix here? Initially, we assume that all the element for of this particular matrix is 0. Okay. Now, if we look at this particular graph, okay, so what we are saying, whenever there is age from I to j, whenever there is age from I to j, right? So in that particular case, so we generally represent m as like this m I j. So I is basically a row and j is basically a column here. Okay, so you can see this are like that. Okay. Now, what about this particular element 0 and 0? So M00 means 0th row, 0th column. M00 means, can I go from 0 to 0 here directly?
No, sir.
No, there is no self edge like this. There is no self edge like this. So we cannot go from 0 to 0. That will be a 0 only, right? Can I go from 0 to 1 here? 0 to 1, you
Yes,
can
sir.
see. Yeah. So whenever there is age from one node to another, we represent by 1 here. Otherwise 0. So I can go from 0 to 1. So I will represent this as 1 here. 0 to 2, can I go 0 to 2? Yes. You can see this is basically 1. What about 0 to 3? This is also 1. What about this 0 to 4 here?
0. It is not possible, sir.
Yeah. So we are looking for direct edge, okay? Not via 1 or via any other node here, right? So here we are saying about direct edge 0 to 4 here. That is basically what? 0 here, right? So this is basically rows. These are the rows, these are the columns here, right? So Mij, this is I, we represent this as J. So M03. So 0th row, third column is basically one element, right? Like this.
Excuse me, sir.
Yes.
Sir, I actually had a power cut, so I could join just now. So could you please just briefly tell what has been discussed briefly
No,
till now?
we have just discussing about the graphs and adjacency matrix here. So first we have discussed about undirected graph and directed edge here you can see. And then we are just taken one example here of one graph and then we are trying to draw adjacency matrix for this particular graph here.
Okay, thank you, sir. I mean, could you please just briefly give the information what has been discussed? Means what the thing you taught briefly, not go deep into it. Briefly, I could join just now because of power cut.
Yeah, just now we have started, just 4 minutes back only. Okay, so this is what we have covered as of now. So we have considered one graph here. So you can see 0 to 1. There is age from 0 to 1. It means what? I can go from 0 to 1 here. But I cannot go 1 to 0 because you can see it's a directed age here, right? If you look at this 0 and 2 here, I can go from 0 to 2 as well as 2 to 0 here. In both the directions I can go because there is no directed graph, direct edge here, right? So if there is no direction, we can go from both the nodes, or we can go to both the nodes like this. If there is a directed edge, it means what? We can go from that node to this particular node only like this, 0 to 1, not from 1 to 0. Okay.
Okay.
And then we have considered this adjacency matrix. And you can see here we have 5 nodes. So 0, 1, 2, 3, 4, right? So it will be a 5 by 5 square matrix. You can see here. And first 0 to 0. So here we represent matrix like this, M, I, J. I means row, J means column here, right? So 0th row, 0th column, you can see this element. I cannot go from 0 to 0 here. There is no self edge here. So that's why the element for this particular thing will be 0 here. Again, 0 to 1, yes, 1, 0 to 2, yes, 1, like that. Okay. Now, what about 1 to 0? Can I go 1 to 0?
No, sir.
No.
No. So that will be a 0. 1 to 1? No. 1 to 2? No. There is no direct edge. You can see here 1 to 3? Yes. 1 to 4? Yes, like that. Okay. So in this way, we create the adjacency matrix. Whenever there is edge from node I to J, we consider 1. Otherwise, we consider 0 here. Like that. Okay. So if in the exam, if we give a graph here, you should be able to draw adjacency matrix. Suppose if we give adjacency matrix, you should be able to predict the graph from that particular matrix here. Okay.
Excuse me, sir.
Yes.
So if I had to go from 1 to 1, is there any way to represent it or is it not possible?
It will
we
be
can-
represented by 0.
Like this. If there is a edge like this from 1 to 1, then we can say, or we can go 1 to 1 here, right? Direct edge. It's a
Okay.
self loop here. You can self edge here.
Okay,
Okay.
okay, sir.
Sir, but is an edge from one vertex to same vertex at all possible?
Yeah, in some nodes, we can go 1 to 1 directly, okay, like this. So we represent this as self loop here. Okay.
No, means is it possible? Means does it exist?
No, right? But if in notation, we
Yeah, in some
generally consider
conditions
like,
it may exist.
yeah, in some condition we exist. Okay. 1 to 1.
Okay, thank you, sir. Sir, I just want to confirm one thing since you kindly told me what was done. This graph you have taken is a set of vertices and edges, and this is a directed graph because few edges contain unidirectional edges. Am I right?
You can see, yeah, we have a directed edges here. Yeah. And we have
Uh,
undirected edges as well. It's not a fully directed graph or undirected graph here. Okay. We cannot represent like that. Okay.
So is this graph
Uh,
directed or undirected?
No, we cannot. It's not both. Okay.
Sir,
Okay.
because in maths also we are having a graph
Right.
this week. Sir, just a little want to remove a confusion. In mathematics, we are told that 1 to 1 means a self a path is not allowed.
Yes. Self path is not
But
allowed.
in
Yeah.
CT we are taking it. It's possible, is it?
If there is a self edge like this, if we represent like this, then it is allowed. Yeah.
Okay.
Yes,
Okay,
I was asking
I would
in
just
this
like
only.
to
Means if
clarify.
self-edge, is it possible at all? Means is it
I would just
meaningful?
like to clarify that in the maths lecture, it was mentioned for that particular case, self-edge is not possible.
Okay. But if self edge is there, then we can go 1 to 1. Okay.
Yes,
Okay,
sir, got it.
Yes, sir, got it.
So here we are not considering any self edge here. Okay. I think in the lectures also professor has discussed this one. Okay. So same thing, we can go for all the edge nodes. 0, 1 we have done. What about 2? 2 to 0 we can go. 2 to 1 we cannot go. Sorry, 2 to 0 we can go. So it will be 1. 2 to 2 we cannot go. 2 to 3 we have a directed edge here. Yes. And 2 to 4 also we cannot go directly. Okay.
Excuse me, sir.
Yes.
So I just wanted to confirm that this adjacency matrix we are representing the I and J are basically the vertices themselves. Am I right? Means
ING
here
are the nodes or the vertices of that particular graph. Yes. Yeah.
means
So
instead of if it was 0, 1, 2, 3, 4, if it was 2, 3, 4, 5, we would have represented that only 2, 3, 4, 5 vertically, 2, 3, 4, 5 horizontally. Am I right?
sorry, nodes 2, 3, 4, 5 like that.
Yes, it means the 0, 1, 2, 3, 4, it will be for all adjacency matrices or just this only. Means I am asking that along the I set, along the J set, we are representing the vertex values only. Am I right?
This only, yeah. So here both I and J, okay. So I and J can take values from this 0 to 4 here for this particular graph here. Or if you are saying like this, if we have just node like from starting from A, B, C, like this. So in that case, you can consider that also, right? Or 2, 3, 4. So 2, 3, 4 here, 2, 3, 4. Okay. But generally, when we create this graph, we always start with from 0. Okay. Otherwise, if the graph is given directly, A, B, C. In that case, you can consider M of AC will be H from, there will be H that will be 1 here, like that. Okay, equal to 1 here, like that. But when we say create matrix n by n, in that case, we consider 0 to n minus 1 rows and columns here, right? That is square matrix we have.
Means we always have to start from 0 even there is no 0 vertex.
No. If in the question we have saying that let's consider A equals to create matrix n cross n, right? So it will create a matrix of 0 to n minus 1, that particular thing you have to take. Start with 0 here. Okay. So indexing will start from 0 here. 0 to n minus 1. So here we have 9 rows and 9 columns, right? So 0 to n minus 1, like that. Numbering will go from 0 to n minus 1.
I mean, this is what I was only asking, that example you gave in the red color, that the vertexes are 2, 3, 4. So we will represent it like I rows is as 2, 3, 4 and J rows as 2, 3, 4, or we will take as 0, 2, 3, 4 only. That be at the bottom, the example you gave.
This one, no?
Yes, here also we have to start from 0. That 2, 3, 4 ABC, that example you gave.
No, that depends on you. We have just writing down the node number here, right?
I think it's just the index for the values in the nodes. We done that for indexing for that in the computation.
Yeah, here we have started with a 0 here, right? So see,
Yes.
whenever we
Indexing,
see
we always do indexing from 0
0 to
onwards.
n, yeah. So we always start indexing with 0. That's why I have taken the example. But if this graph is given, so we can ask m2, 3 equals to 1 or not. But you will find out we always start with a 0 or either 1 here, okay, in the graph. So don't worry, we are just discussing if there is a age from node I to J, then it will be 1, otherwise 0. That's it, okay? Just remember this
That part I
important point.
understood, that
Yeah.
age will give 1 and no age will give 0. I am
Just
asking
that's
about
it
the
only.
column and row headers. That
No,
in the
that,
I rows, the column
that
header
will be given in the question. Don't worry. We'll discuss along with the question, okay? Don't get confused here.
Excuse
Just
me, sir.
understand. Yes.
Sir, in math activity question, means it is given that the relation between two nodes is represented by two head arrow. So we will consider it as directed or undirected.
Two head arrow.
Yes, sir, double head arrow.
Like this.
No, sir, means in side of
The arrows, yeah,
and
there are
I to J
arrows
and
at
both
J
J.
to
side
I.
arrow.
Okay, so that will be undirected graph.
Undirected.
We can go from both the side, I to J, J to I, both the direction. Right? In that
But
case,
sir, maybe in that answer it is given that it is directed.
okay, we have to see what is covered. It is directed, but we can go in both the directions here, right?
So
Like
if
that.
there is any rule that undirected is represent only by a line.
So undirected means that it can go from anywhere to anywhere, right?
Here, I'm just talking about node I to J here, like this.
Yeah,
Okay.
in case of I and J, I can go to J and J can go to I. That means undirected, right? So both sides should mean undirected.
Yeah.
In the
So I need
maths,
to check the diagram. If the other nodes are also there, then it will be directed only, right?
they told that if it is the directed one has only one arrow. In undirected, there will be two-sided arrow. That's why we simply don't take two-way arrows.
Yeah. So both the things are, you can see this also undirected, you can consider. We can go on both the side, I to J, J to I. Here also we can go in both the directions, I to J, J to I. Okay. So different notations are there, but don't get confused here. Okay. Either we can follow this particular thing, only single line, or both the arrows is also fine here, right? So we are going in both the directions here. Okay. Yeah. So see, okay, so in this way we can create adjacency matrix. Similarly for node 3 also we cannot go to 0. Yeah, we don't have arrow here, so we can go to 0, 3 to 1. Here you can see arrow is from 1 to 3, not 3 to 1. So we cannot go from 3 to 1. 3 to 2 also we cannot go directly go back here. No. So that will be also 0. 3 to 3 also no. 3 to 4 yes 1 like that. Okay. So this is how the adjacency matrix has been drawn. We have just discussed one example with the help of a graph. So how adjacency matrix is created for directed and undirected edges for both. Any doubt here? What we have discussed up till now? Just remember what's adjacency matrix here. That's it.
Sir,
Huh?
if let's say there are multiple nodes, if
Mhm.
only one of them is directed, meaning a single arrow, does that mean the entire graph is directed?
No, we cannot say it's a direct
So
or
does that
undirected
mean
graph.
the
In
entire
our
graph is undirected? Because it has to be one of them, right?
So
Yeah,
actually,
so
in
we'll
our
not
maths, that in the graph it was told that even if all the other edges are undirected and only one edge is directed, then the whole graph will become directed. To become undirected, all the edges need to be
all the
undirected. That
okay.
was told in our maths. So is it
Yes,
applicable
sir.
here?
Yes, then this
If
is
you
yeah
see the
directed graph. Because if you
okay,
see
Sir,
even in the one edge here, we cannot go from this to this side. That will become a directed graph, right? It will restrict the path we are going to get from that particular graph here, right? So yeah, we can say it's a directed graph here, right?
sir, I
Because
posted a question in the chat. Can you please tell it is directed or undirected? It's too much
yeah, I will
confusing.
go through that question.
Excuse me, sir.
Yes.
Hello,
Yes,
hello.
tell me.
Sir, till now everything you said I understood. Just one query that was I'm trying to ask that here the coincidentally the vertex are also 0, 1, 2, 3, 4, and the fact you said that the index starts from 0 to n minus 1, those two are matching. But my question from the beginning was just this, that if the vertexes are not 0 to n minus 1, suppose random like 1, 9, 17, 19, these are the vertexes, then what will be the row header and the column header for the adjacency matrix? This fact could be explained. Could
Okay.
I
See,
give my query properly?
no, no, yes, I understand your question. So we are saying A, B, C, or any random node starting
Any
from
random.
2, then 3, then 7, 8,
Yes,
like
yes.
that, right?
Yes. Then what will be the row headers and column headers for the adjacency matrix?
No, see, here we can start with 2, 3, 7, 8. Okay. So what we are trying to learn here, whenever we represent the adjacency matrix, whether age exists or not. So if I say M23, right? So here you can see there is a age from 2 to 3. That will be 1 here, right? So in this case, I and J can take these values only 2, 3, 7, 8. In this case, I and J can take values from 0 to 4 here, like that. Okay.
I means could you if you don't mind, could you please the just now the example you gave, could you please just write the row headers and column headers for the matrix like the previous one you created? 0 and 1 we need not to populate, but just the
See, if we have this particular matrix, we are only trying to understand whether the age exists or not. That is what adjacency matrix will give us, right?
okay.
So here you can see, you can just use this one like that also, okay? M2 to 3 means what? Can I go from 2 to 3? So Mij here. So here in this case, what we are seeing, the value of I and j can take 2, either 3 or 7 or 8. We have 4 values here. In this case, I and j can take 0 to 4 here, like that. Okay?
Okay, so it is not that for every matrix I need to start from 0, 1, 2 up till the order.
No, no. If the graph is given to you, if no graph is given, we have just consider the adjacency matrix of 3 by 3. In that case, you have to start with 0, 1, 2, like that. Okay.
Okay, thank you, sir.
Yeah. So if you see in this particular question here, you can see we have n by n matrix, right? So
Yes.
that is what we have to consider, n cross n. So starting from 0 to n minus 1, we can go. Okay. But if graph is given along with the node, then you can only follow this. Otherwise, I have just said consider a square matrix of n by n or 4 by 4. In that case, you have to start indexing with 0. Okay.
Okay, so means if just the order is mentioned, then we have to go from 0 to that n minus 1. But if
Yeah.
the graph is explicitly mentioned, then we have to take the values
Then
of
you
those
have to take the
vertices.
node, whatever the node notation we have.
Okay, okay. Thank you, sir. Thank you.
So in few questions, you can see we have traveling across the cities, Mumbai, Pune, Chennai, like that, right? So in that case, I will consider this particular graph, Mumbai to Pune, Pune to Chennai, like that. We have few questions based on the trains data set. Can see here. Yeah, you can see train data set. Okay. Okay, this is about the adjacency matrix here, right? So we'll try to discuss the concept using examples. Okay, we'll see. So here, first thing is that you should know how these adjacency matrices are constructed. Okay, and then how to replace this particular data here. If I say M2, comma 3. So what is M23 here? M23, M2, and third column. That is basically 1.
Second row, third column.
Second row, third column is 1. That is will get replaced by, let's say, for example, M23 plus 1. Okay. So whenever in the loop, this condition gets satisfied for some condition, then we'll add 1 to that like that. So this will become a 2 here, like that. We will do some operation with this particular values based on some condition, right? In that case, we have to increment or add or so perform some operation with that particular value. It can be 0, 1 here in the case of adjacency matrix, okay? Like that. Okay, I hope how to construct adjacency matrix is clear to everyone, right?
Yes, sir.
Okay, what is direct and undirected graph here? Okay, so direction means can only grow from
Sir, can you give
one
another
node to
example
another
of
node.
it? So can you give
Another example?
another example of adjacency matrix?
Yeah, so you can see here, let's say, for example, I have just a node like this. So starting from 1, 2, 3, we just have 3 nodes here, okay? And this is basically directed graph here. So in the matrix, we have 1, 2, 3, 1, 2, 3 here like that, okay? So here we have 3 columns, 3 rows. So here I can go from 1 to 2 here, 1, 2, 3 here. Can I go 1 to 1? I don't have this self each here, right? No. So 1 to 1 will be 0. 1 to 2 I can go. 1 to 3 I can go like that. Similarly, 2 to 1. Can I go 2 to 1? No, because there is a direction. So
Because
2
it
to
is
1
directed.
in 2 to 2. No, we don't have a self edge again 0. 2 to 3, that will be 1. So like that, we construct adjacency matrix for a given graph here. So whenever there is an edge, we consider 1, otherwise it is 0. Okay. Same thing for this one here, 0, 0, because we don't have any arrow going
Sir,
out
will
from.
this recording be available in case I have to refer?
Yes, it is available. Okay. Now, if you consider this particular graph here, okay. So what is degree of a graph? In degree, out degree?
Most number of
Anyone?
nodes?
Number of incoming nodes and number of outgoing nodes.
In
Like
degree is the number of
there's
nodes coming
outgoing
towards the vertex, and the out degree is number of edges going out of the vertex.
Okay, what is the in degree of a node 1 here?
0.
0.
How many incoming arrows we have? So number of incoming arrows. Coming arrow. So for node 1, you can see we don't have any arrow, that will be 0. Out degree of
2.
node 1,
2.
number of arrows, that is 2 here, like that. And total degree of this particular node will be incoming plus outgoing arrow, that is basically 2 here.
Excuse
Okay.
me, sir.
Yes.
Sorry, sir. Actually, in our maths part, it was mentioned that for a directed graph, in degree plus out degree does not equal to total degree.
No, for that particular node, I am saying.
Yes, that was only told. Means for if the graph is directed, we cannot sum the in degree and out degree and tell that it is the degree of the vertex. In degree is separately and out degree separately. That was in maths part told. So would it be applicable here in the same way? Or maybe
I need to check in what context. Which week in this graph we discuss? 11. Okay. Math.
No, in maths week 10 only.
Week 10.
10. Okay. We'll discuss, right? But as much I understand is in degree and out degree of node. And here we consider this in degree plus out degree will be degree of that particular node here. Okay.
Okay.
Okay, so this about the graph, and we have few other concept. We'll try to discuss using example here. And you can see here we have a data set. Okay, so okay, so see here, right? So entire this week 9, 10 based on the graph theory builds with the dictionary here. Okay, so you can see we have this question based on the trains data set. There are n number of stations with station being indexed from 0 to n minus 1. So you can see it is mentioned in the question 0 to n minus 1. There are m rows in the table. If in the question they have mentioned index from 1 to n, so you have to consider 1 to n, right? Otherwise 0 to n minus 1. There are m rows in the table. You can see m number of rows. Each row contains information about the train that connects two stations. Every row, you can see will just give us the information about a train that connects two stations without any stops in between. So train number this one, departure, arrival, and you can distance travel from 0 to 1 here. Okay. And you can see 0 to 1 is basically what? The stations we have. Okay. So from station number 0 to station number 1, it travels 266 kilometer here, like that, by this particular train number here. This is given to us. For example, you can see rth row tell us that train D departs from station I and arrives at station J after traveling a distance 3 kilometers without stopping at any intermediate station. Okay. So rth row is consecutive rows in the card for train D and train data set. Therefore, each train D will occupy the multiples in this table. Yeah. So you can see here. So trains are going through multiple stations. So train number will be repeated here. Okay. Then we have scenarios model as a graph and represented by a matrix A. So what is this matrix A here? Each node in the graph will correspond to a station here. Assume that we have value of n is already given to you. Consider the following pseudocode. So here n we have number of stations. Okay. Let's say for example n equals to 5. Okay. So we have 5 stations here. Okay. And let's say starting from 0 to n minus 1. So 0, 1, 2, 3, 4 here, like that. And for understanding purpose, we'll consider city also. Okay. So let's say Mumbai, Pune, Chennai, Delhi, and let's say Kolkata. So here we have 5 cities and we have, sorry, 5 stations we have. Okay. And we have just given the name to understand the example in a better. Okay. So you can see, so departure travel 0, 1, 2, 3, 4. We just have 0, 1, 2, 3, 4 in this particular both the columns here. Okay, and the distance traveled by way. Now let's see what we have. We have S as an empty dictionary here. While table 1 has more rows, read the first row X in table 1 S of this sequence number here. So what we are trying to do, S basically empty dictionary here. So what this will create? Yes, anyone? What will happen at line number 4? Let's say
Empty
sequence.
nested dictionary.
Yeah. So let's say for example, we have considered 5 stations, right? N equals to 5. Let's say 0, 1, then 3, 3, 4, 5, 2, again 4 directly. So here we have this one 0, 1, 2, 3, 4. Train number 1, 5, 9, 6, 0, 1, 5, 9, like this we have. Let's say distance 3, 3. So here we have the information about the tree. And you can see here, first row, right? First row from the table will be first sequence number here, 0 sequence number. What we are creating? We are creating a dictionary here as. The first element of the sequence number, that is 0. And the what is the value? Empty dictionary.
Empty dictionary.
Right? This will happen at line number 4. What about line number 5?
We will add
Yes.
the key value train in the empty dictionary of with key 0.
So 0, then at this point, we are going to this dictionary, and again, we're adding a key here, that is train. The corresponding value will be what? That particular train number here, 12259. Huh? Yes.
Sir, sorry, sir. I will not be able to attend the research children right now, but I am just asking, will it be available after the class so that today only I can refer to? Just I have not got some work.
Yes, you can check the calendar. Recording says there. Okay, this is going live.
Means will I get it on calendar on YouTube? This class recording?
Calendar. Check the calendar.
Okay, thank you, sir.
Okay, so here we have a train, right? And what about this line number 6? Again, in the same dictionary, we are adding a departure here. Depart, that is basically 0. Same thing, arrive, basically 1. And distance is 66. Okay, so what we have done here, we have created one empty dictionary S, and then we have added a key sequence number, the value empty dictionary again here you can see, and then we have followed this particular lines here. So we have entered this particular sequence number, it's an empty dictionary. We have added a key train and the corresponding train number, depart, corresponding departure and arrival station. Okay, is this clear to everyone what we have done, how this while loop is working?
Yes, sir.
Yes,
And
sir.
this for first row here. We'll go back to while loop, then we'll go for a next row, that is basically sequence number 1. Same thing will happen here, comma, then we have 1 like this, 1 again, same thing, train numbers 1, 2, 2, 6, 0, depart is basically 2, arrival is 3, and distance travel is what we have 300. Okay, so this is what will be there. So at the end of this particular while loop, what we are going to get, as in that we have the key 0, 1, 2, 3, 4, and the corresponding value will be what dictionary, in that we have train, departure, arrival, distance. Okay, so this will be for all the 5 rows here like this, 0, 1, 2, 3, 4. Okay, I am not writing it down, but I hope you understand how this dictionary S will look like. Same for 2, same for 3, and same for 4. Right, same train, departure, arrival, distance will be there. Any doubt here? I hope you understand how this dictionary will get filled, right?
Yes, sir. Got it.
Okay. So you can complete this particular thing. Now, after completing while loop, we'll go to this line number 12. Here we have A equals to create matrix n by n. So we have to create a square matrix of order, and n is basically 5 we have considered, right? Now, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 we will get for each R in rows of A. Rows of A will be what? List of the vertices, that is 0, 1, 2, 3, 4. Columns all will be the same thing. So whenever you see these rows of A, columns of A, this will be a list of vertices of that particular graph. Okay, always remember rows and columns of. Now what we are trying to do for each R in rows. For the first iteration, R will be 0.
Sir,
Yes.
sorry to interrupt, but rows of A will indicate the labels like sequence numbers, na? Rows and columns.
Yeah, of that graph here, vertices of the graph.
Oh.
Right. So here we have considered n here, and you can see station will takes from 0 to n minus 1. Right. Okay. Now, this is basically list of vertices. Okay. Rows of A, columns of A, or in some question we'll just mention list P, and we'll define that list P is basically list of vertices. Okay. You can see previous year questions like that. We have mentioned list B, and list P is basically list of vertices of this particular matrix. Okay. So for each R in rows of A, R is basically 0. So we'll fix R0, and we have this inner for loop here. For each C in this particular column here, A of RC was to empty dictionary. R will be 0. For each C in column C, initially C will be 0. So what it will do? Yes, anyone tell me what this will create?
Empty matrix.
Adjacency
Empty
matrix.
nested dictionary.
Empty dictionary, but
Empty nested dictionary actually.
Nested.
Nested
Sir,
dictionary.
adjacency matrix.
yeah, so it will create a matrix A of n by n. So 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, like that. Now here we have fixed R, that is zeroth row here. So 0, 0. So A of 0 and A of 0 is basically what? Empty dictionary here. So the matrix 0th row, 0th column, can I create an empty dictionary like this?
Yes, of course.
Yes,
Yes,
sir.
of course.
Right.
Sir.
So
Now,
empty dictionary for each element.
yeah. Then we go back to again inner for loop. C will be what? 1 here. So A 0 and 1, 0th row, first column, again empty dictionary. Again we
Yes,
go
sir.
back
Yes,
to
sir.
inner for loop. So again C will get changed to 2. So in
It
this
will
way we are
create
going
all
to
the empty
create
dictionaries,
empty dictionary for
all
every
the
element.
columns and rows, all the
Yeah.
M and J's, R and C's.
Now once if I go for an inner loop and we have covered the both vertices as well, we don't have any other vertices, we'll exit the for loop, we'll go for outer for loop, and here R will be 1. So again same thing here like that. Okay. So we are going to create a matrix of 5 by 4 or 5 by 5 matrix here, and all the elements will be empty dictionary here, right? Any question? Anyone? Is this clear?
Yes, sir.
Yes, sir.
Okay. So we have created a matrix A, 5 by 5 matrix here, and all the elements are initially empty dictionary here. That's it. Okay. So we have discussed this point. Now for each X in keys of S. What is keys of S here? Yes, anyone?
Rows.
Keys
So
of
0,
S,
1,
as
2,
you
3.
already
Train. 0, 1, 2. Train is to
So it's the sequence number, right?
It will be
yeah.
list
It
of
will be
Keys
rows.
of that
Yes, sir.
particular dictionary. List of
Yeah, it
the
will be
keys rep.
rows, but it will be rows of the sequence number.
this will be list of the keys of S and S. Basically dictionary here we have. So keys of S will be what? 0, 1, 2, 3, 4, right?
Yes.
Yes, sir.
Yes, sir.
S we have created using this particular while. So from here we got S. From here we got A. Okay. Now for keys of S here, right? So initially for X in keys of X, X is basically equals to 0. Now R as 0 depart. What is this? R equals to S of 0 depart. So
It will check the departure of the first
No, it will
like,
assign. It will
We
assign
are assigning value
zeros
of departure
what is to R.
of first sequence.
No, we are not assigning, we are taking the values.
No,
the
we are assigning
initializing.
that. It's a
we are
No,
equal
taking the
no,
value
sign.
from this
R is storing
dictionary.
the
We are
value of
assigning the
which is
value of
present.
R.
Yeah.
Yes.
Yeah, that's what I meant.
It's assigning.
So you can see R equals to this particular value. What is this? S of 0. So we go to this 0 key here. And then depart is basically this one. Value will be
Departure.
0. R equals to 0, right?
It will store the departure
Yes,
Yeah,
Yes, sir.
departure
of
0
the
here.
zeroth.
Yeah, 0 station. Again, what about C? S0 arrive is basically 1. What about T? S0 train.
It
Train
will store
number.
the train number.
S0 distance, we store a distance here, right?
Distance.
Any doubt here? What this RCD will store for this particular value, right? For this value, we are going to enter the dictionary with 0 as a
The
key,
dictionary.
and we are getting the value corresponding to the keys here: departure, arrival, train, and distance. Any question, anyone? I'm getting a
No,
background
sir.
noise.
No, sir.
Okay, great. So now what we are doing here? Yes, anyone? What is this? You got the
We
value
are
of R,
taking the values.
A, 0, 1, then we have 1, 2, 2, 5, 9 equals to 266. Now take me, what is this?
Triple nested dictionary.
It is storing the edges in that position, the key and the value pair in the dictionary, empty dictionary.
Okay. So
Position.
what is A here? What is A we have created?
It's an adjacency matrix.
Matrix of
This
empty.
one, right?
Mhm.
What is A, 0 and 1?
It's a position
Zero
of zero,
is the
zero row and first column. That is
0
second
row, first
position.
column, which we have empty dictionary, right?
Well, in that dictionary, we store the key as the train number, and in as the value, we store the distance.
This is basically empty dictionary. Whenever we have a dictionary in square bracket key, it means what? We are adding that particular key here, right?
Yes.
And the corresponding value will be T.
Yes.
So can I write this as like this? Dictionary T is what? 159 colon 266. Can I write like this?
Yes.
Yes, sir.
Yes, sir.
So this is what we are doing here. We have created a matrix A for 0 and 1. 0th row, first column, and basically empty matrix we have. Then we have to add this particular key, that is a train number, and the corresponding value will be a distance. Okay. It's for x equals to 0. Then go back to another for loop, x equals to 1 here. Okay. X equals to 1 here. So again, R1 of departures, R1 of departure is basically a 2. Remember this one. R1 of departure is 2, arrival is 3, train number is 160, distance 300. It means what? Tell me directly where I need to update the matrix A. Tell me.
Second row, third column.
Second row, third column.
Second row, third column. Second row, third column will be this one, right? M23. Yeah, M823 will be this one. And here we need to add 12260 and the corresponding value will be 300. Okay. So this is what we are doing here. For every station, we are adding the train number and the distance it has traveled. Okay. Okay. Now let's say, for example, I'm adding one more. We'll update this 60, 0, and 1 is 250. Okay. Now consider this particular row here, right? So here we have departure, station number 0, arrival 1, traveling to 50 kilometers for train number 12260, right? Now, if you consider that particular row here, what will happen here? Tell me. So what will be the value? Back here. So we have a sequence number 3 here, right? For a third sequence number, when x equals to 3, what will happen when x equals to 3 here? 3, 3, 3. Departure arrive will be what? 0 and 1. So this will be 0. This will be 0. This will be 1. Train number 12260 and distance is 250. Now tell me what will happen here, the adjacency matrix for that particular station when x equals to 3. Yes.
We will add another key in the dictionary on the level or on 0th row and first column.
0th row, first column. We already have this one, right?
We will add another key, sir.
Yes. So that will become 12259 colon 266 comma 12260 colon 250, right?
Yes, sir.
Yeah. So see, I'm not considering another row because we have few more rows here, and for that we are also considering this particular case here. So whenever we have two different train going to the same station, so we are going to store it like that here. Okay, you can see we have a two train here going to a same station 1 and 2. So we have added the information in A, not 1, 2, 0 and 1 here, right? Station 0 and 1 here. A, 0 and 1 here, like that. Okay. Any question how this matrix is getting created? How this dictionary is getting created
Can you
here?
explain the last step one?
Okay, so we have considered one more row here. Let's say, for example, this third sequence. we have train number 12260. Departure is 0, arrival is 1, station number we have, right, 0 and 1, traveling a distance to 50 kilometer here, right? So for that particular row here, we have followed this, and what we got at A01. So train number this one, distance is this one, right? So we have to add the new train number with its distance in this particular dictionary here, right? So for the same station, we have two trains going through the same station here. Okay. Hello. Did you
Yes, sir.
understand this one? What I have discussed? This one part. Okay. If you understand this one, now tell me what this will give us. Tell me length of keys of A of 0 and 1 here. Yes.
So number of trains that have same.
Number of train going from
Number of
station.
train going to station 0 and 1, right?
Yes, sir.
Arrival 0 and departure is 1. 0 to 1 we can say, right? Okay. So let's try to solve the question here. If you understand like what we have discussed, let's see. If IJ is a pair of station, which of the following statement about dictionary AIJ is true? Okay, so this is about this particular matrix here. So each key corresponds to a train that goes from station I to J without stopping at intermediate station here. Is this correct?
Yes, sir.
So here each
Yes, sir.
key represents a train number that goes from I to J without stopping any intermediate station here. Yes.
Yes.
What about option number B? Each key corresponds to train that goes from I to J. It may stop at multiple station. No.
No, sir.
Here we already considered this particular case here, departure, arrival without stopping at any station in between. So anyway, option B is not correct. What about C? Is C correct? The value corresponding to that particular train key T of distance is the distance between station I and J on T's route. You can see this particular value, right?
Yes.
It's the distance between 0 and row station here. So option C is correct, right? So minimum distance, no, we have not talked about minimum distance here. So option A and C are correct here. Anyone, any doubt in this particular question?
No, sir.
Right? So simple. You should understand what the pseudocode is doing here. And importantly, is this one is A and this for loop here. Okay. So here we have created a matrix A. Here we have created a dictionary S, and we are using that it here. Okay, in the for loop. So for every row we have this sequence number we are trying to create a matrix here. Okay, we are going to store information about the station I and J, and the corresponding value will be a train number going from I to J, and the value will be distance here, right? Now what about this one? Already discussed this one.
Yes, sir.
So tell me which option is correct.
Option B.
Number of trains that goes from station I to J. We have not discussed anywhere stopping of station intermediate station here. No. Without stopping, yes. This can be correct. Without stopping J to I, no. Here, not like
No.
that. D, at most, no. So option B is correct here. Okay. So simple one, you should understand what this matrix is doing here, how this matrix is getting created. That's it. Based on this only the question has been framed. Okay. Okay. Anyone, any
Yes,
doubt
sir.
what we have discussed? Okay, great. So here we have this one, question number 3 based on the same matrix. Okay. So IJ mean is a procedure that accept two station IJ and the matrix A as the input. That A we have created in this particular question here. Right. So remember, whenever I say MIJ, it means what? In that matrix, we have the information about the train going through I and J, and the corresponding value will be a distance covered, right? That is what we have stored in this particular matrix A. Now it returns a train which goes from I to J by covering the Least distance without stopping at any intermediate station here? Yes. If there is no train connecting these two stations, the procedure returns -1. Okay. If there is no edge from I to J, it should return -1. Okay. The pseudocode may have a mistake. Identify all of them if it is a MSQ question here. Now here we have a procedure. It accepts I, J, and A as an input. If length of this one equals to 0, it is going to return false here. Is this correct? This if statement here. What if statement is checking? Yes, anyone?
The number of trains going from station I to J.
Yeah. So number of trains going from I to J. If that is equals to 0, it means what? What we can say? There is no train from I to J, right?
Yes.
Yes, sir.
If there is no train from I to J, what it should return?
-1.
Minus
So what
one.
is returning? False. So here we have
returning.
a mistake. It should be a -1 here. Line number 3, we have a mistake. Now we have a train equals to first of keys of AIJ. Now tell me what is this? First of keys of AIJ. What this will
Train
return?
number. Train
So
number.
keys.
First train number of that
First train.
element.
No, see, AIJ is basically what we are going to do. What is keys of AIJ? That is basically train number here, right?
Train number.
So first train we
Yes,
can
sir.
say a train number. What about mean here?
Distance.
Distance.
Distance, right? For that particular train here. So let's say, for example, we'll consider this scenario. A01, we have two trains here, right? So consider this one, A01 here. And then we have 12259, 266, 12260, 250 here. Okay. Now keys of, let's say for example, ING 0 and 1. That is basically what? So here we have additional keys will be a list here 12259, 12260, and here train will be first element of that will be this one, right? 12259, and we are going to use this 12259 here. So A of IJ 12259 is what? What's the value corresponding to this? Yes, anyone?
Distance.
Distance covered by that
Distance.
train, it is 266 here. Now what we are doing here, for each k in rows of AIJ, rows of AIJ,
Train
what is the
number.
rows of
Train
AIJ?
number.
We'll checking the dictionaries in the each position of the adjacency matrix. The dictionary in the adjacency matrix.
No, here rows of AIJ. What is A of INJ? What is this one?
We are iterating through a list of train number
No, no. What is
of
this A
AI.
of IJ here? We have a dictionary here like that, right?
Yeah.
So we have a dictionary here. What is rows? It's not a correct one here, right? Rows of dictionary is not there. Rows of matrix is there, or we can say it's a list, right? So for each in, this should be a list here. But what is rows of this matrix? I think this is not a correct line number
Train
7. Yes, line number 7, we have error here. So this is
So
not
it should
The
be
keys, not the rows.
it should be keys, right? Correct. It should be keys.
We should have keys there.
Yeah, this should be a keys because this is what we have a dictionary here, right? Rows is not a correct here. We use rows for a particular matrix here. We can say rows of A. That is a matrix here. That will give us list of the vertices here. But we got a dictionary here. So the correct thing is we have to use keys of that particular dictionary. That will give me a list of the keys here. Okay, so it should be a keys. If I use keys here, so this will be this only 12259, 12260, right?
Yes.
Now
Yes.
for the first iteration, k will be 12259. So again, distance equals to 0, 1, 12259. Again, that will be 266. 266 less than 266, not true. Not true. Go for a next one here. Next is basically 12260. So next element is 12260 and the distance will be 250 here. So 250 less than 266. Here that is true. So we are going to store 250 here. Train will be 12260. So we are going to get a train which travels the minimum distance here. Right. So where it is? Least distance here. Right. So we are going to get our requirement thing here. Now in this question, line number 3 is error. Line number 7, we have an error. It should be -1 and it should be keys here, right? Any
Yes, sir.
doubt what we have discussed in this question? Rest of the code is correct because we are getting what we want here. Okay. So this should be keys and this should be -1. Okay. So whenever you come across this particular case, always check what is there inside of
Sir,
this one function, right?
sir, just one thing, the first, third line error, can you explain once more? Just a little brief.
So in the question, it is mentioned that if there is no train connecting these two stations, it should return -1 here, right? So here we have a if statement. If length of keys of A, I, J, it means what? It will give us number of train going through I and J, right? I to J here. If that is equals to 0, it means what? There is no train connecting I and J, right?
Yes.
So it should return -1, but it is returning false here, right? It should be -1.
Okay.
Okay.
That's clear.
Yeah. Okay. Great. So you can see correct answer is A and D here. Okay. Great. Question number 4 here. Let ij be a pair of station. Which of the following statements are true after executing the pseudocode given below here? Right. So here I to j is basically we have created one variable I to j that is basically false. If length of this one, what is this now? Tell me. What do you understand this?
Not equal to 0.
Yeah. Then what it mean?
It will
Number of trains
number
I
of
to J.
trains have
Means
the
there
path.
is at least one train that passes through I and J
Yes.
station.
So there is at least one train that goes to I to j, right?
Yes.
If this
Yes,
is
sir.
true,
Yes,
then I to
sir.
j will be true. Then we have j to I equals to false. Again, length A. Here you can see we have first j and then I. It means what? We are going from j to I here. Okay. If this is not equals to 0, again same thing here. It means what? There is a train from j to I. Then this will become true. Right? Now
Yes,
here we have I both j equals to false. If I to j and j to I both j will become true here. This pseudocode is given to us. Any doubt in this pseudocode?
No.
No, sir.
Only thing is this one, right? So we have already discussed this one, right? If it is not equals to 0 means what? There will be a train from I to j. Now what you can say about this one? If I to j is true, if this is true and j to I is false, then I both j will be true. Is option A correct?
No.
no, sir.
No, sir.
No, sir.
No, because
They
I
should
both j,
be true.
yeah. So for this to be true, this condition must be true. And this will be true
Yes,
only
sir.
when both are true, right?
Yes, sir.
So option A is not correct. What about B?
Yes, sir.
Yes.
True.
Yes,
Yes,
sir.
sir.
It's
Correct.
Correct.
Yeah. What about C?
Correct, sir.
Correct.
Uh,
Correct, sir. It's correct. Because it I and both J are true, then both J, I to J and J to I should be true.
Okay, and this also correct. Okay, B and C is correct because initialize with false. Okay. Yeah, then fine. What about option number D?
No, sir.
No, sir.
It's false.
We cannot say if I
Correct.
both J is false,
Both
it
are
means both
false.
are
Then
false. No, which is not true, right? Even one of them is false, then it is also going to get false, right? So we cannot
Yes, sir.
say. What about E? Again, same thing. We cannot say anything about this one. What about F? Again, same thing. We cannot say. What about G?
True.
Yes, sir.
True, sir.
True,
Correct.
sir. Correct.
Correct, sir. It's taking or.
Or, okay, yeah, correct. I missed this or. Then it's false or this is false. Yeah, so option G is also correct. So B, C, and G is the correct here. Yeah, correct. Simple question. We just need to check here this particular uh, thing here, nothing to do with. But you should understand what this length of keys are doing here, right? Yeah.
Yes.
Yes.
Okay, great. Question number 5. We have sum proc is a procedure that accepts 3 parameters: train, station, and the matrix A. Again, what we have created in the first question, right? Which of the following statement about its return value are true? Okay. About its return value are true. Okay. So let's discuss this pseudocode here. So it will take train, station, and A as an input. For each R in rows of A, what is rows of A here?
Sequence number.
Station name 0, 2, 1, 2, 3, 4, right? We have considered n equals to 5 stations. So we have 5 stations here. What
Yes, sir.
about this one? What we are checking here is key. This should be train. Okay. So is key is basically a function which will check whether the key is present in this particular dictionary or not. That's it. If it is present, then it will return true.
It is checking the condition is checking that is the train passes through that station or not.
A
If
of
it has a key.
R station. Yeah. So what this will do? We are checking whether train number is a key in this particular dictionary or not. What is this dictionary? A, R, and station number. Okay. So station number, let's say for example, 3 here. Okay. And let's say train number is basically, let's see. Okay, so we have station number 3. What we have considered here 0, 2, 1, 2, 3, 4. And let's say we have a Delhi here. We have a matrix A, station number 3, and then we have a train as an input also. So let's say, for example, 1, 2, 2, 6, 0 here. Right? So what we are trying to do here is keys A are of station number is 3. Okay. So we are going to check for each R in this particular rows, which we will go from 0, 1, 2, 3, 4 for this particular station number. It means what? We are going to check whether train number is a key in this particular dictionary or not here. Okay. Let's say, for example, R equals to 0 initially. So 0 to 3. So in the A matrix, 0 to 3, we have it is 0 and 3, this one. So whether this particular train number is a part of that dictionary or not. That is what we are checking here. Are you getting my point?
Yes.
If train number is part of that dictionary, then it will return true. Otherwise, we'll go to next station here. Okay, next station, next value of R here. Now, if this is true, if train exists, then we are checking for each C in columns of A. Again, same columns of A will be this one. If is key A, now A station, C, train number, and then we are going to return a false. Otherwise, it will return a true here. Now, what we are doing in the inner for loop? Yes, anyone?
We are checking that same train is going through other station.
Okay. See, here we have R, here we have station, right? If R2 station, if there is a train, then this will be returned true, right? Hello?
Yes.
Yes, sir.
Now, when this will be true, when station to C, same train goes from station to C here. Same train. What is this? A of station C will do. Again, it will check whether this train is a part of this key or not. So here we are saying, it's for example, input is 3, right? It means what? This will return false when the train will go from R to station and station to C here. Like that, same train, right?
Sir, R and C are also station.
Yes, RS is also station here.
Sir.
Because if you see, we represent like this, right? I and J. I, J is row and column. So this will, if you see this, look at the matrix. We are saying where it is 0, 1, 2, 3, 4. It's an n by n matrix what we have created here for n number of stations, right? Indexing from 0 to n minus 1 here. Okay. So you can see here.
Sir, I think R is the arrival time and C will indicate as a departure time in the pseudocode in the first problem.
No, that is here you can see here. We are not considering this one, R and C. Okay. Arrival and departure, right? It's not a time, it's a station. Station name here. Okay. It's not a time here. It's arrival station, departure station here. 0, 1, 2, 3, 4. So here we have 5 station like that. It means what? This train number is going to station 0 and arrive at station 1. So that's why I have considered this one, 0 Mumbai, Pune. So it means what? Mumbai, Pune. So this train has traveled from Mumbai to Pune via 266 kilometer, directly 266 kilometer like that. So here departure arrival is basically a station name here. Okay. That's what is mentioned in the question itself. We have n number of station, index from 0 to n minus 1. And you can see departure and station I, right? From station I and station J. Okay. It's a station. Yeah. So you can see here. So this is clear, right? We are checking whether train is the key of this particular thing or not. It means what? This train is passing through R and R2 station, right? R2 station here. Then we are checking for which C, means for which station this will get satisfied. A station C train. Same train will go through station to C here. Station to C. So this particular diagram. R2 station is station to that particular station C here. Both the conditions are true. We are going to return false, right? If this condition is not true, it means we are going to return true here. Okay, it means what? We just have a train from R2 station. This station is not, this train is not going anywhere from station after that. Okay, like that. Now, let's read the option. Yes.
Sir, so in the inner iteration, we are technically saying that if the station is the starting point, then it's returning false.
Not starting
The inner
point.
iteration.
This one, na?
Sir, in the inner one, the next if.
Okay, here. Next if. So station to C. So station is a starting station, that is departure, and C is basically arrival here.
Yes, sir.
So we are checking whether any train is there which will go from station to C. Okay, same train here we are discussing about.
Yes, sir. Okay, sir.
Yeah. So we'll
Sir,
read the
but there,
option. Yes.
sir, but
Yes,
these
go ahead.
train are not same as they mentioned already that a train can't stop at a single station, like immediate stations.
Yeah. You can see for this particular train, first it will go from R2 station and then it will go from station to C, right? So directly we are going here. We are not stopping in between. It is mentioned here that whatever the distance is mentioned here, we are going directly from 0 to I here. Okay. Without stopping any station here. Okay, so read the option, then it will be much clearer to you. What about option number A? This will return true if station is the starting station for a train.
No, sir.
No, sir.
No, sir.
Station is last.
No, last is also not correct. Huh? This station you are talking about, this station, right? This will return true. Okay, yeah, we have to check. Right. This will return true if it is the starting station. No, because this will. Yes, this should be a true here. So this will be a this one.
It will
Yeah, it
return
should
the
be a
So it
last,
should be
right?
start from R and end in station.
Station. That will be means it should be a last station, right?
Yes, sir.
Yes.
Yes,
It
sir.
A is
could
not
not be
correct.
C.
What about B?
True.
What up?
True, sir.
It will return
It's a
false
station.
if station is the starting station for train.
Yes,
No,
sir.
sir.
No, sir.
Return false. So it can return false here as well as here, right?
It will be false. It is not correct, sir.
Starting station for train. Yeah, starting station we cannot say it will return false. Yes, correct. What about C?
True.
True,
Yeah,
sir.
ending station
True,
because
sir.
after that if we
True.
go it will return false. So option C is correct.
It's true.
What about D?
Return the false if station is
It's false.
Not
Returns
true, sir.
Not correct.
returns false if station is the ending station for train. Ending station for that train, then it will return in true. So anyway, it will not return false. What about this one?
So it is also false. It should not be intermediate. It should be
False,
final
sir.
state.
immediate.
If station is interstation on the train's route, on the train's route, you can see like this, but it is returning false. What they are saying true, not correct. What about F?
True.
Correct.
True.
Yeah.
True, sir.
So this will return true. Sorry, wait, false, right? So this will return false when we have a train going from R to station and then station to next station is basically C. So intermediate is basically a station here. So we can say this will be true. What about G?
Not true.
True.
Not
Not
true,
on the
sir.
train's
Not,
route.
it's
If
false.
it is not on the train's route, it will return directly this particular false, right? This one. So no, that is not correct. What about H?
Yes, it's true.
It's true.
True, sir.
So you can see B, C, F, H, right? So F, H, B, and C are the correct ones here. Okay. So yeah. So here we are checking whether it's a key or not. Key means what? Train is going through this R to this particular station here. Again, we are checking whether key is present or not. It means what? The train will go from station to C here. This particular diagram. I hope this is clear now. Going to the options, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. Great. Okay. Next question 6 to 7. Okay. Assume that there are n station in the train data set, same 0 to n minus 1. Graph with the station as node. There is an h from station I to j, if and only if there is a direct train from I to j. So we can say there is h from I to j if there is direct train from I to j. The graph represented by a matrix direct such that direct ij equals to 1 if there's h from I to j, otherwise 0 here. That's a matrix we are saying. Assume that direct has been already computed and direct is non-symmetric matrix here. What is non-symmetric matrix? Yes, anyone?
Their opposite row and column values are not equal. Opposite.
The transpose of matrix is not equal to the original matrix.
Sorry, can you repeat?
The transpose of the matrix is not equal to the original matrix.
Okay, transpose of that matrix not equals to original of matrix. Yeah, we can say that A is not equals to A transpose, right? It means what? There exists at least one element such that A of ij is not equals to A of ji here, right?
Yes, sir.
At least one is there. Then only we can say like that. So it means what in terms of train? Tell me.
The train that is going from I to J does not went from J to I.
No, sir. If there is a
Mhm.
train going from I to J, there shouldn't be any train going from J to I.
Okay, we'll see. Station J is reachable from I if we can add a non-empty sequence of trains that take a passenger from I to J. So it is saying station J is reachable from I if we can uh, add a non-empty sequence of trains that take a passenger from I to J. The word J is reachable from I if there is a non-empty sequence of edges that connects I to J in the graph. Okay, reachable we are talking about, not the direct one here. Okay, so here we have I, A, B, C, and J. So I can reach to J via like this. Okay, so this is what reachable we are saying. J is reachable from I if there is a non-empty sequence of edges that connect I and J in the graph here. Okay, like that. The following pseudocode computes a matrix V of identical dimensions as direct, so same as of this particular matrix, such that V of ij equals to 1. Again, if only and only if j is reachable from I. Okay, so here we have two matrices, that is direct and V here. Okay, so what's the difference between these two matrices if you read the question carefully? Yes, anyone? Tell me. Yes. In the case of direct matrix, I can directly go to I and J without any intermediate station, right? In the case of matrix V, I can go to I to J either directly or via intermediate station, like that. It means there is a path from I to J like that. Okay, that's what reachable we are saying here in that particular case. Okay, I hope this is clear about direct and V matrix. Here we are saying
Yes.
direct train between I to J, but here we are saying I to J we can go via station A and B like that. Okay, now let's see. And length of keys of direct. So we have what is direct here? Keys of direct. So again, number of stations here, right? Same. We'll create the square matrix of n by n for same number of station. So B and direct both are the same matrix here. Okay, initially n cross n. For each r in rows of direct, let's say for example 0 to n minus 1. For in columns of direct 0 to n minus 1. What we are doing here, V of RC equals direct RC. What we are checking is anyone? What we are doing here? Just understand this particular part. Yes. Simple thing here. We have a two for loop. We are going through rows and columns and we are doing this
We are
operation. What is
assigning
this?
same as
Huh.
BRC matrix
Yeah. So
as
we
the
are
type.
whatever the direct matrix we have, we are simply creating a matrix V, a copy of that, right?
Copy of that.
Yeah. So same thing we are doing here. We are creating a copy of direct matrix, which is basically B here, right? And what is direct matrix here? We have a train from I to J directly. Okay. So already this matrix B will have the information of the direct train here like this. So B and D is same here as of now. This till this point, right? Can we say like this?
Yes, sir.
Okay. Now let's see hopes equals to 0. We have one variable while hope n minus 1 is starting from 0. So 0 to n minus 1 b equals to one more hope. What is this? We need to check the procedure here. Okay, we need to complete this one. Okay. So one more hope for each r in rows of b, for each c in rows of b, we have to return b here. Okay. Okay. So what is b here? B is reachable. which is reachable from I here. Okay. So B is what here? B is going to take, okay, original matrix as an input for initial case. So this will be taken as an input, and we're updating that particular matrix here. Okay. So here we're updating the original matrix here. Okay.
Yes, sir.
Yes, sir.
Okay. So let me draw graph 0, 1, 2, 3. Okay. So 0 to 1, 1 to 2, 2 to 3, 0 to 3, and that's it, right? So 0 to 2, let's say 4 also. Yeah, 3 to 4. So here we have 5 stations, right? So we'll create 5 by 5 matrix. Okay. So I'm not drawing the adjacency matrix here because I hope you will be able to assume what is adjacency matrix will look like for this one. Whenever there is H, it will be a 1 here, right? Now let's see here. Hope is equals to 0, 0 less than n minus 1, n is 5. Yes, that is true. We are going to take D as an input. So initially same matrix here, right? Now what we are trying to do here? For more row, for R in rows of B, 0 to 4, columns of B, 0 to 4 here, right? Now let's see here. What about the first option here? For each columns of B, again for each K in columns of B here. R, C, and here we have a K, okay? C equals to 1, exit the loop, okay? If R and Q is equals to 1. Okay, so we need to create this matrix B here, reachable, right? So let's see. Okay, consider this matrix only 0, 1, 2, 3, 4. Now, what about this one? Can I go to one node here? Let's say I to J via any intermediate node that like this. This is what we need to check it here. Okay. So for each K in columns of B, what is this? B R C equals to 1. So here we can see R and C, and here we have this K. So if B R C equals to 1, we need to exit the loop. Is this correct?
No, sir.
No, sir.
Why no? RC means what? There is H from R to C, right? It means I can go from R to C.
Then we are finding here if R2 is reachable. Right? C is reachable by R. So what if it is a direct connection?
Already there is a H from R to C. It means we can go from R to C, right? So we can exit the loop. We can know, or we can see here there is a direct H from R to C. Now, if this is not correct here, right? If R to C is not equals to 1, then we check this here. If B R to K equals to 1, so R to K is 1, and K to C is also 1, and K to C is also 1, then can we say B R C equals to 1?
Yeah. Yes, it's
Yes,
reachable.
sir.
Yes, sir.
It's reachable, showing that.
Yeah. So we can go R to K and is there, right? If it is
It
or,
is-
then that will not be true. So here we have and, okay, remember. So R to K, I can go R to K and K to C. It means, can I say R to C? Yes, equals to 1. Then we're going to exit the loop here. Is this correct, exiting the loop?
Yes, sir.
Yes, sir.
Okay. What about option number B here? We'll see this looks correct. As of now, we'll see option number B. For each K in columns of B, if RK equals to 1 and KC equals to 1, it means RC equals to 1. Is this correct?
The code is correct, but I think it should also have the direct checking the connection of direct. Is it equal to R to C? Is directly connected or not?
Yes. Okay. because if you see here, this is we are inside the while loop here. Okay, if you go for a next iteration here, then in that case, again the input matrix will be taken as a again the updated matrix will be taken as the input here. Okay, so we need to exit, yeah, that loop. So A looks correct. B also same thing, but here if there's a direct H between R to C, again we are unnecessarily checking for that particular case here. Okay, so
But we are not exiting.
we are not exiting the loop as well. Yeah.
Yeah, that's it.
Also K so different values of K here, right? So we need to see here. There's a possibility of reaching the C via different K value also, na?
It's
Are you getting
missing
my
the
point?
return value it has.
Okay, so let's say for example, if we have R and C here, so it will start from 0 to 1, 2, 3, 4 like that, right? So it will be 0. Let's say for example, here we have R is 1 and C is basically 2 here, right? Now it can be 0 as well, 1 to 0 and 0 to 2. This is also possible. It can be 3 as well, 1 to 3 and 3 to 2 also, right?
Yes, possible.
Yeah. So here we are directly exiting the loop after we got one path only. But there can be multiple paths as well, na, to reach that particular node.
Yes, it's possible that we have another part also.
Yeah. So here what we are saying, R to C. Let's say for example, here we have 2 and 3. R to 3, 3 to C. This is correct. Here also R to 2 and 2 to C. This is also correct, right? So we have to update both the things here. R to C equals to 1 and R to C also equals to 1. But in
We have
any
to
way,
record
it
every
will be.
reachable path.
Yeah, but it will update to only once only, right? So anyway, it will not get affected because we are simply checking reachable or not. How many paths we are not keeping a track of that, right? So anyway, it will work in the same manner, but this is the case here. Okay, we'll see other options. What about this one? For each k in rows of B, R to K, K to C, R to C equals to 1. R to K, K to C, columns of B here. Rows of B here. No, again that first part, this part should be there. We'll see option number D. For each k in columns of B, if B R to K to R equals to 1, K to C equals to 1, R to C equals to 1, can we say like this? Completely wrong, right? K
Yes,
to
sir.
R we have and K to C we have. It doesn't mean that we can go to R to C, right? No. So option D is anyway not correct here. So we left with A, B, and C, and the correct options are A, B, and C here only. Okay. So see, in the first option and the remaining two options was a difference. Here we are exiting the loop. If we know that there is a H, it means we can reach from R to C here. Here also it will get B equals to once only. But here we are going to exit the loop once we found the one particular loop here. Here, even if we have multiple things, we are not counting how many roots we have. We are simply updating the value of 1. So at the end, in the matrix, it will be equals to 1 only, right? Even though we have a multiple roots here. So option B and C are also correct here. Okay, we are not exiting the loop here. We are
Option
simply
B and C are correct because it's undirected graph. Sorry, it's a directed graph. That's why, like, because in
no.
one case we have columns, other we have rows.
We are only checking for reachable from
Oh,
I
okay.
to J here, right? Now, how many paths we have to reach that particular point that we are not considering, right?
Yes, sir.
Here we
Say
just got
P
one
to
path,
R
we are
to
exiting
one.
the loop here.
Hmm.
But here we are not doing that. It will go continuously even though we got that particular path. We check for multiple paths. But anyway, we are not updating the value of that one. It is equals to 1 only. Okay.
Sir, what
Yeah.
does this exit loop means here?
Exit loop means what? If this condition is true, right? So here we have a for loop here, right? Now, if this condition is satisfied, then we don't need to go for our next iteration here, right? That's why we mention exit loop here. So if we have this 0, 1, 2, 3, 4, and let's say when k equals to 1, This condition got satisfied, so we are going to exit the loop. If this is not present, then we have to go for k equals to 2, k equals to 3, k equals to 4. For all the values of k, we need to iterate through this for loop here. Okay, that's it.
Okay, sir.
So if this condition got satisfied, we are exiting the loop here. So all the three options are correct, but the difference is that we are only checking once here whether we can reachable to that particular R to C or not. And here we are not worried about how many times we can go to that particular edge. Okay, we are only simply updating it to 1 here. Okay, so anyway, A, B, C, all three are correct here. Okay, anyone, any doubt in this question? Okay, great. Now here we have a graph n equals to 5. Matrix we've already computed using the above pseudo code. Okay, now B is how we are reachable to that particular node. That is what we are trying to achieve. So here we have sum equals to 0 for each R in rows of B. Rows of B is 0 to 4. Columns of B is also 0 to 4 here. Right? Sum equals to sum plus the RC here. Right? Now let's say R equals to 0 initially. C equals to 0 initially. So do we have H from R to C? 0, 0. So no, you can see here. Then 0 to 1. Yes, we have 1. Then plus add 1. 0 to 2 plus 1. 0 to 3. Yes, plus 1. 0 to 4 plus 1. 0 to 5. 0 to 0 also reachable, right? Right.
Yes, sir.
It's reachable.
Yeah, so we can reach directly like this. So this will be also 1. So 0 to 0, 1, 0 to 1, 1, 0 to 2, 1, 0 to 3, 1, 0 to 4, 1. That is basically 5. Now C is completed. Go for a next one. R is basically 1. Now 1 to 2, 1 to 3, 1 to 4, 1 to 0, 1 to 1 also reachable. So again 5. So here for this 5, 5, 5, 5, that will be total 25 as the answer here. Anyone, any doubt here? How we got 25 as the answer? We are only checking whether we can reach from R to C. If it is there, then we are equal to 1. Okay. So you can see we can reach 0 to 0, 1 to 1 also, 2 to 2 also here, right? Like this from 2 to 2 here, that will be again equals to 1. So for all the nodes we can reach from this particular graph, for this particular graph, so it will be 1, 1, 1, 1, 1. That will be 5. And we have
So
a
can you
5 such nodes.
explain it one more time?
Okay. So here we have rows and columns of B, that is 0 to 4, right? For the first iteration, R equals to 0, C equals to 0, right? Now, what is this? B of 0, 0. Now, what is B here? B here is basically what? Reachable from I to J. That's it, right? It is equals to 1. This is what we have find it out here, right? Now, can we go 0 to 0 here from this for this particular graph? 0 to 0, is it reachable?
Yes, it's
Yes, we
reachable.
can go like this. We can go here, 0 to 0. That is 1 here. Right? Then go for next iteration. C will be 1. Can I go 0 to 1? Yes, directly we can go. That will be again 1. Again, go for next iteration. C will be 2. Can I reach it, go 0 to 2? Yes, 0 to 1, 1 to 2 directly. Again, plus 1 like that. Okay. So once we complete the inner for loop for 0 here, answer will be 5. Then go for outer for loop for R equals to 1. Same thing will be repeated here. Okay.
Okay, sir. Understood.
Yeah. So it depends on what is B is doing in the previous question. B is simply equals to 1 when we can reach from node I to J. That's it. Okay. So here we can reach from this node, from any other node. So will equals to 1 there. That's it. Okay. How many questions we have? 9. So after this, please try to solve the question by your own and please attempt the grade assignment questions because deadline is 13th only. So please try to attempt the questions. Okay. Similar type of questions are there only. And if you observe here, we are only dealing with what? The matrix and the dictionary here. That's it. Okay. Now we have a pseudocode execute using a train data set as discussed in the lecture, trains and dictionary map to a station. Okay. So here we have a trains dictionary. Now we have a train number, and this is basically list of stations which that trains run through. Okay. In this example, train with a train number, this one start from Bhubaneswar and reaches to New Delhi via Balasore, Agra, Varanasi, Kanpur. Okay. In this particular order only. Okay. Let com number L1, L2 returns the number of common elements between the list L1 and L2. Observe the following video code and the given answer. Okay, these are questions. Procedure to something train. Okay, so here we have a do something. It will take a trains, which is basically a dictionary as an input here. I0 index is basically a dictionary. I hope this is clear, right? So this is we have a train number. List is basically what? A station name. And in this order, this train is going through Bhubaneswar, then Balasore, then Agra, then Varanasi, then Kanpur, and at the last Delhi. Okay, like that. This train, a path is there. So here we have index, again empty dictionary. For each T in keys of train. What is keys of train? Yes, tell me.
Train number.
List of train numbers. So here we just have 12281 here, right? Let's say we have two more train number here. 12261, which goes through, let's say, Mumbai, then it will go through Jaipur, then Delhi, like that. Okay, New Delhi. Let's say 12262 here. This will start from, let's say, Chennai, so then it will go through Varanasi to Srinagar. Okay, last Srinagar. So this is basically Srinagar. Here we have 4 stations, here we have 3 stations, and this is basically one train here. Okay. Now for each T in keys of train, so keys of train. So let's say we have a train here. So keys of 3 will be 12281, 12261, and 12262, right? For this example, we have 3 trains here in the dictionary. Now, what is index TI? What is this as anyone? What we are doing here? T equals to this one for initial iteration. What we are trying to do here?
So assigning values to train by making another dictionary.
So index is basically an empty dictionary. Then we are putting T as a key there. So that will become that train number 12281. And the corresponding value is basically I. I is 0. Okay. I 1. Okay. Then we go for a next train. Next train will be 12261. I will be what? 1 here. Right. Then we have 12262. I will be 2 here. So what we are doing here, we are assigning the index value to the train number. Can we say like that?
Yes, sir.
Right. So for this train, we have 0 for this train, 1 for this train, 2. Okay. Let's see the code. Sign equals to length of keys of index. So number of, just tell me what this will give us.
Number of trains.
Keys of index. So keys of this particular index will be this train number. So number of trains is basically we have 3. So we have this one C station, create matrix of n by n. So we'll create a matrix of 3 by 3 for each T1 keys of train. What is keys of train here? This one
Train
list
number.
of train number. Okay. For each T2 in keys of train, again same the list of train number. What we are checking here, yes, tell me, if T1 is not equal to T2, what we are checking here?
Both the trains are different.
Means train numbers are not same. The train numbers are different. In that case, what we are doing, this common station index T1, index T2 equals to this one. So this common number will return number of common element between the list L1 and L2 here. So tell me what we are doing at line number 14 here. So here we have an empty dictionary created 3 by 3. Index T1, index T2. Let's say, for example, T1 is basically 12281. Then we go to T2. T2 is 12281 initially, but it should not be equal. So we'll go for our next iteration. And here T2 will be 12261. Okay, both the trains are different now. 12281 and here 61. Here we have train 12281 and here we have 12261.
Sir,
Now what
com
is
number, what
this?
it returns? Yeah, sir.
This will return number of common element in both the list. You can see here, right? And it will take two lists as the input and it will return number of common elements here. So here we have two lists, trains 12281, trains 12261. It means what? The list of stations here, right?
So a list of stations where both trains, I mean, is going basically.
Yeah. So train of 12281 is basically this list. Train 12261 is basically this list. Now out of these two lists, which are the common element? That is what we have to find out here. That will be a stored at this index position. So this will be what?
Yes.
Index of T1. What is index of T1 here? 0. And this will
0
be
rows.
1. Okay, so at this matrix, 0, 1 will be number of common station here. So if you look at Mumbai, Jaipur, New Delhi, and here this train, we just have New Delhi as a common. That is basically number of common element is 1. So here that will be 1 here, right? So in the CSTN matrix, we have at 0th row and first column, we have this 1 as an input here, okay? So CSTN 0, 1 will be equals to 1. Go for next iteration, T2 will be 12262. Again, both are not equal. Now 12281 and 12262. Now, how many common station we have? 62 is this one, Chennai, Balasore, Varanasi, Srinagar. So Balasore and Varanasi, we have two common station here. The output will be 2 here, right? So CSTN 0 and 2 output will be 2 here. CSTN 0 and 1 output will be 1 here, right? Are you getting my point what we are doing here?
Yes, sir.
Right. So we are going through all the for loop here like that. What we are returning? Station, this basically matrix here and the index position here and the index, dictionary here as well. We have not updated the dictionary here, I guess. Have we updated? No. So index matrix will be this one. Index will be this one over here, right? Dictionary. We have not updated anywhere in the code. Okay. Now what about this question? Just read the question here. What happened? Yeah. If CSTN ij is equals to 0, for I is not equals to j, then which of the following statement can be concluded here? Right? Is option 1 correct?
No, sir, we are not counting the routes. We are just counting the number of common stations.
Yeah. So there is no route between station with index I to j using one hop. No, we have not discussed anywhere about the hop. We are simply finding out the common station here. I is not equals to j. What about option number B? Is this correct?
Yes, sir.
There are no common trains between the station with index I and j. Yes, if it is 0. What about C? Okay, wait. This is not
On
correct.
the route.
Between the stations we are saying here, on the route of the trains with index I and j here, right? No common train. Common train, no. We have discussed about the common
Common
station.
stations. Yeah, got it. Yes, sir.
Okay. So option C is correct here. I also got confused. Yeah, option C is correct here. Okay, so please read the options carefully. We are discussing about the station, not the trains here. Okay. Anyone, any doubt here? If you understand this particular statement and if you directly look at this particular code, now you can easily answer that particular question. That's it. Okay. Even if you didn't understand this particular part. Okay, we'll see next question here. Assume we start our journey using a given train T. Now consider the following procedure that should return true when it has at least one common station with all other train. Okay. Okay, with all other train here. So which one will be a correct? We want to find out the train which will have a common station with all other train here. Okay, that is what a train number here we are taking and in dictionary as an input here. Is this correct? Common matrix index do something train. What is this do something train we are doing here? Yeah, so this will give us number of common station between. This will return station and index. Okay, so it will return station and index here. Yes. So it will return the number of common station between both the trains along with the index dictionary here. Then k equals to index t. Okay. So for that particular train, we are going to take the index value here. Then for each I in columns of this one, this matrix, and if I is not equals to k, same at k of I equals 0, return false, else return true. Is this correct here? Will it return true when the with at least one common station between T and the all other train? Yes, anyone? Common station means what? C mat I of j must be some equals to some numbers, right? It can be 1, 2, it can be anything. It cannot be equals to 0. Equals to 0 means what? There is no common station between I and j here, right? Like that. Now check here what we are doing. Is this correct? If there is no common station, then it should return false. Otherwise, it should return true.
Yes, sir.
Right, so we are checking for I equals to j. When I is not equals to k means we are not dealing with the same train number here, right? So if you are not dealing with the same train number, then common matrix equal k of I equals to 0 means there is no common station between the two trains here. Then we are returning 0. So this will true if both the conditions are true. Then we are going to return false. Otherwise, if this condition is not true, then it will return true here. Is this correct?
Yes, sir.
Yes, sir.
Okay, we'll see. What about option number 2 here? Not option number 2. I guess, yeah. Procedure 2 here. We'll see. Procedure, again, same T and trains count 0 for each T2 in keys of trains. Common this train T1 greater than 0. What does this mean? Greater than 0? It means there is some train, some station is common between both the trains. Can we say like this?
There is some common.
Yes, sir.
Common station. Then we are counting it out. Okay. We are finding it out. Okay. Then if count equals to length of keys of train. This is basically what?
Sir, is it asking for at least one, right? So even if we found one, then we should not continue, right? It is like it is counting the total, right? So,
No, we don't know what this count is doing. We'll see here.
okay.
Okay. So if this is true means what? At least the one station is common between both the trains here, right? It will increment the value of count here. Okay. So
at that point itself, we should come out, right? That, okay, there is something. So it is like it is keep on incrementing. So it will count like.
So this count will be like this. If we have 3 train 1, 2, 2, 8, 1, 1, 2, 2, 6, 1, 1, 2, 2, 6, 2. And let's say for example, all the trains. Okay. Yeah. So we have some common. So if this is true, 8, 1 and 6, 1, return 0, count will be 1. If we go for the next loop, 3 to 10 number will be different. T2, let's say this is 62. Again, we have then count will be equals to 2. Okay. So it means what? This T train is having common station between two trains here, right? What this count is giving us? Can we say like this?
Yes, sir.
Yes, it
Let's
is
say we
counting.
have
common
6,
across
0,
all.
5, 9. And here we have no common station. Let's say, for example, between 1 to 8, 8, 1, and here we have common station here. Okay. So we have a common station with these three trains, not this one for this particular train here. In that case, what will happen? See here. So first common uh, greater than 0 means what? There is a common train between T and T2. So T2 is basically this one here, right? Keys of train. It can be same train as well. So anyway, it cannot be possible. We have a common station. It will be greater than 0. So count will be equals to 1. Okay. So let's say, for example, this is T. This is my input, and we have this 5 trains. Okay, in the trains data set here. So T2 will be what? Keys of trains starting from this one, 1 to 2, 8 to 1. So this is 8 1 is fixed, 8 1. Anyway, all the station will be common, so it will be increment by 1. Next iteration, 61, again common, 2. Next iteration, 62, again common, that will be 3. Next iteration, 60, it is not common, okay, will not increment. Next iteration, 59, it's common, that will be 4 here. Okay, so this train has a common between value of 4 means what? Along with own like sale train here, what we can say, we're considering the same train also, right? So that is what account will give us here. And if we have this as well, so it will be a 5 here. Now, if count equals to 5 and length of keys of train is also 5 here, then we are returning true here. So what we are doing here, are we checking here if that train is having common station between all the trains here?
Yes, sir.
Yes, sir.
Right? If suppose we don't have a common station between 60 0 here, that will be 4. So count will be 4, and this will not be equals number of trains. In that case, it is going to return false here, right? Are you getting my point?
Yes, sir.
Yes, sir.
Okay, let's see what's the question here. Which of the procedure works as indented? And we want to find out that only whether common station is there or not. So both the things will look correct, but here what we are checking, I is not equals to j, right? It means we are not comparing the train with itself here, right? But here we are also checking that also, right? Count equals to count plus 1, the number of keys, right? So that's the only difference, I guess we'll see. Only procedure 1 works correctly, 2 correctly, both works correctly, neither of them correctly. Both the procedure works correctly, but the difference is that here we are also considering the comparing with itself. Here we are not doing that. Okay. So both the pseudocode will work perfect. Anyone, any question? I hope you understand this one. And what's the difference between procedure 1 and 2 here? Here we are comparing with itself, but here we are not comparing with itself. Yes. Okay. Anyone, any question? So in this type of question, especially in the case of a trained data set, try to take some examples, some dummy examples, and then you can easily solve that particular questions here. Okay. Try to take 3, 4 train number or station number, and then try to implement that pseudocode here. Otherwise, if you take just 0, 1, 2, 3, then it will make a confusing. But try to take some dummy example and try to implement the code on that example. Okay. So option C is correct here. Both will work perfect. Okay, great. I guess that's the last question. Yeah. Anyone, any doubt in week 10? Anyone? So that's it from my side. Please try to solve this question again, okay? So here I have just discussed, so that's why you think you understand. But if you try to solve it by your own, you can come across more questions as well, okay? So we'll get more doubts. So please try to solve
Can
the
you
question by your
share
own.
this PDF in
So can you
chat?
share the PDF? Yeah.
This PDF is basically a solution document only.
Sir, these are activity questions.
So practice assignment question. Week 10, practice assignment question, okay?
Okay, sir.
Thank you, sir.
Okay, thank you. That's it. If you have any question, we can discuss in next session. Okay. So we just have 11 week content in CT course. So next week we have more time to discuss about if you have any the city course. Okay. Okay, that's it from my side. Thank you. Bye bye. See you.
Thank you, sir.
Excuse me,
Yes,
sir.
Chetak, you
Thank
have
you.
any?
Thank you, sir.
Chehak, sorry. Yeah.
Sir, I have a question from quiz 2.
Yes, tell me what is your doubt here?
Sir, I have sent you in the chat. Can you please say that?
A should represent number of noun in the last sentence. Particular sentence. Okay. A should represent. Okay, let me share my screen. That will be easier to explain. Is your question visible? Hello?
Yes, sir. Yes.
Okay. A equals to do something. W list. B equals to A. Okay, so W list will first create the list of part of which for all the words here, right? This is what W list will do. Part of which for all the words. A word end with a full stop. Yeah. So first W list will create, okay, till the word end with full stop. Do something W list. Okay, so we are just taking that particular sentence here. Then we are counting for each P in L. P is basically now count equals to 1 represent count here. Okay. The value of A will be number of noun in that in the sentence, in the given sentence, right?
Yes,
Hello?
sir.
Right. So then after that we are comparing A greater than B, then we are putting B equals to A. And S list will be what? S list plus W list here. So S list is basically what we are doing here. Empty list is there. And W list is we are adding into that. Okay. And we are making W list as empty here. And then we are going for a next iteration. Okay, great. So after every sentence, W list is getting empty here, right?
Yes, sir.
Okay. Then what's your question here? Correct only, no? At the end of execution, you A represent what, right? This is what you are asking. So at the end of execution, you can see W list will be empty here. So yeah, we can say A will be a number of nouns in that particular sentence, right? Whatever the sentence will be, that one. Yeah. What is your doubt? Any question here?
Sir, my doubt is that A should represent the number of nouns in the last sentence, not that particular sentence or something.
Present in the last sentence. Consider. Use quiz two question, not this time,
Yes,
for
sir.
previous term.
Quiz 2. Quiz 2.
Here W list will be empty at the end, right? So if you look at that, the end of execution, W list will be empty here, right? So yeah, we cannot say like that. It will be for a particular sentence only. It is counting number of nouns, right? Yeah. Option. Which options are there? A number of nouns in a particular sentence only there. This is correct only.
Sir, my doubt was raised because in the last option, it is written W list represent the list of part of speech in the last sentence. In the fourth option, it is mentioned that it is the last sentence, but in the third option, it is not mentioned.
W list represent the list of part of speech of the words in the last sentence. W list, no, W list will be empty. That is not anyway correct here. Okay. W list will be always empty at the end of execution here. Okay. S list will represent the part of speech there. Yes. Yeah. S list will represent the list of part of speech of entire words data set here, not W list. Yeah. Option D is anyway not correct. And you can see it will store number of noun for a particular sentence only here. Yeah. Okay. Okay. That's it. Thank you then. Thank you. Bye bye.